All right, here we're going to go and start talking about logarithms here today. Last week, again, what we were looking at was the idea that we were going to deal with all the exponential stuff. And again, logarithmic functions and exponential functions, what they are is they're inverses of each other. So they're important because we need them to undo each other. So if we get looking into it, here's your definition from the book. The log function y equals log base b of x. That's how that's read, log base b of x. Where b has to be greater than 0 and b can't be 1. We'll talk about that in a second. Is the inverse of the exponential function x equals b to the y. Okay, so y equals log base b of x if and only if x equals b to the y. So that's what that last statement is saying, because your if and only if piece right here, okay, that's this notation right here. Okay, so a couple of things. Why does b have to be greater than 0? Well, it comes into your exponential piece, and if you recall from our exponential stuff, we didn't let our base be negative, because in the graphing piece, what it would be doing is bouncing back and forth over the x-axis, because it's such as -2. When I raise it to the first, it's a negative value. When I raise it to the second, it becomes a positive. So that's why it can't be negative. It can't be 1, because if it was 1 to any power remains 1, so it doesn't change at all. Now, the big thing when we start looking at these is we're going to go from rewriting from one form to the other. And the big thing here, as I always preach, is the idea that b is your base. Okay, and so your base is going to be the same. So log base b of x. Okay, and then it's base of my exponent is b. Now the book uses a, so if you would look at the book, you'll see that. I like to use b because I think people remember that that means base. Okay. So a couple things that we start with, and I brought with the rule here, and it might be something you want to write at the top of your paper as you're looking at your homework so you can see it if you do get hung up. But if I want to take these logarithmic expressions or equations and rewrite them as exponential equations, okay, what I'm going to do is, number one, start with my base. Okay, so I go in and I look at log base what? So it's base 4 in this case here. So it's 4 is my base. Over here, 8 is my base. Now if you go back up here and you look a little closer, when it's in logarithmic form, b is with x. When it's in exponential, b is with y. So I talk about it has to now be with the other piece. It can't be with the same piece twice. So I'm going to have 4 to, not the x, to the 12th. I'm going to have 8, not to the 11th, to the y. And then that's just going to be equal to what's left over. Well, I use the 4, use the 12, x is left. 11 is left. And that's just going from one form to the other. And the purpose of that, again, sometimes we'll see that if I have a situation where I don't know what to do with it in one form, I'm going to change it to the other. All right, so if we go from exponential to logarithmic, same idea. Okay, log, well, start with my base. Base of my exponential piece is 4, log base 7. Okay. Here we're with y, so here we're going to be with 17. Here I'm with -3, so here I'm going to be with 1 over 343. And then equals what is left over. Okay. Now what people get worried about once in a while in this case is, ooh, I got a negative, but that's fine. It's your base right now that you want to focus on not being negative. Okay. All right, so when we get to evaluate expressions, we're not solving, we're simplifying, but I'm going to change it into an equation because I want to know what is log base 7 of 49 equal to. And so I can kind of cheat and turn this into an equation. And here's where I'm talking about the idea that if I can't solve it in one form, let's try the other. So when I look at log base 7 of 49 equals x, I don't know what to do with it. Okay, so what we'll do is we'll try to rewrite it in exponential form. So 7, okay, to the x equals 49. Now there's a rule that actually came up in the exponential piece that we didn't discuss, and it talks about if I can get two powers to be equal, and if those powers have like bases, then those exponents have to be equal. Okay, so what I want to try and do here is rewrite these two expressions in a form where they have the same base, and I can rewrite 49 as 7 squared. Because if my bases are alike, then my exponents have to be equal. So x in this case would be equal to 2. Okay, so same thing over here, the second example, log base 2 of 1 over 16. What's that going to be equal to? I don't know what to do with it. Rewrite it in exponential. Okay, so now I need to come up with a situation where I have a like base. And here you're going to have to start understanding some of your bases. I can see 16 is 2 to the 4th. Okay, they're still not like bases because this one is 2 to the power. And this I could actually look at as 1/2 to a power. Okay, so I have to do some more adjustments yet. And what I can do, because of my properties that we talked about last week, I can move that 2 to the 4th into my numerator. And if I do that again, change in side, so my exponent changes sign. So now I have like bases. Y would be equal to -4. Okay. Now, a couple special situations that come up here that if you remember them makes life a little easier and a little quicker. But if not, it's fairly simple to come in and do what we've been doing. Log base b of b to the 7th equal x. Well, I don't know what to do, so I rewrite in exponential form. So base b, other piece, left over, x equals 7. Okay, this is an exponential this time. If I rewrite it, okay, log base b of my other piece equals all that leftover stuff. Now, we haven't gotten to this property, but I think it's pretty obvious that if I have a log of something equal to the log of something else, that those two pieces have to be the same. And so x is going to be equal to 9. We'll get that property here in a second. But if you see, if I have an exponential and a logarithmic piece all tied together, basically what they're going to do again is they're inverses of each other, so they undo each other, so they just basically, if you want to use the term, cancel out. All right, I'm just going to leave this here for a second because I know there were some questions in class about this one. If you have a question with 14 on the worksheet, just go ahead and pause it and you can look at that. Otherwise, we're going to move on. All right, so on page 720, you got a number of rules. We just got done talking about the equality one, the idea that if I have a logarithm equal to a logarithm, okay, those two expressions are going to be equal. Okay. The product and quotient, I got those tied in with, if you remember from our exponential stuff, if I multiply two powers, I add my exponents. Okay. We're going to go the other way. Now it's if I add my logarithms, we're going to multiply the expressions. You're going to go from right to left with these two properties more often than not, because a lot of times we're going to try and condense them so I can get it to a logarithm equal to a logarithm. Same thing, when we divided, we subtracted, so now when we subtract logarithms, we're going to divide expressions, because again, we're doing the inverse. Okay. The power property, that's going to be one that comes into play. We're going to go both directions with this one. If we're trying to get it into this form again of a logarithm equal to a logarithm, what we have to do is take that number out in front that I'm multiplying my logarithm by and shove it back in there as an exponent. When we start solving and we recognize my variable's in the exponent and we need to take it out of there, we'll take the logarithm on both sides and then we'll slap it out in front. So we'll see plenty of examples of those over time. All right, so here's the one thing I don't want to see people doing is just simply start crossing logarithms off. I think that's where people get in trouble, just crossing off things. But I do recognize here I got the log of something equal to log of something. Okay. Since it is log equal to log, those two somethings must be the same. Okay, and so therefore 3x equals 36, x equals 12. Pretty simple situation. I'm just going to set you up with 22. Okay, I need to get these two to have the same base. 36, sorry, can be 6 squared. Okay, 216 is 6 cubed. But the 6 squared was actually raised to this negative 2x plus 1 power. And so what we have to remember is some of our rules. When I go power to a power, remember we're going to multiply my exponents. Okay. But now I'm sure you can see what we're going to end up with is you're going to go here, bases are alike, therefore exponents have to be equal. All right, and here's why I don't like just crossing off logarithms, because people will do that. And if you notice, we're supposed to stay balanced with our equations when we solve them. So I cross off two things on the right, but only one on the left. What I want to get to again is logarithm equal to a logarithm. And again, they need to have the same base. You won't run into that in this course, but someday you may. So what I need to do is combine these somehow. Okay, and here's that subtraction becomes division. It's always first divided by second. Now because I have logarithm equal to logarithm, those expressions are the same, and I can do cross products and get my solution. Same idea. If I just went in here and crossed off the logarithm on this number 15, I've changed the left side but not the right side. And here's the little hint. Okay, if I only have one logarithm, you're in logarithmic form. And if you don't know what to do with that again, change it to exponential form. So I don't know what to do with log base 3 of x. Okay, so what I'm going to do is rewrite an exponential. So base 3, other piece, leftovers. Negative exponent, take it to the other side, it becomes positive. X equals 1/9. Okay, so do not get in that habit of just crossing things off. Okay. Same idea here. I can't just cross because of the fact that there isn't any logarithms on the right side. But what I recognize is I can combine two logarithms that are being subtracted into division. And when I do this, what's happening is now I'm creating a situation where I just have this single logarithm. So let's switch it to exponential. Now remember, anything to the 1/2 power is just like doing the square root, so square root of 16. Okay. And again, I'm going to have cross products here, which you have to be careful of. Make sure you're taking 4 times that whole denominator. So maybe write it in parentheses first before you distribute, so we make sure we get that -1 times 4. So I know I'm going kind of quickly, but I want to get this done before I run out of time. So I get a equals -2. Now, the thing that you have to be careful of, okay, is if I go back up to my original and I plug in that a equals -1, or -2, I'm sorry. I'm trying to do log base 16 of -3. If you go back to our definition, okay, log base b of x equals y. Okay, our base, they said, had to be positive. We're okay there yet. But now when I rewrite it in this form, okay, if my base is positive, okay, and I'm taking and raising it to a positive power, or I mean raising any power even, I'm sorry, but if I take a positive, raise any power, it remains positive. So my x value is also always going to end up being positive. Same thing here. Okay, so I can't do a logarithm of a negative value. And even if you just take your calculator and try and type in a negative, what it's going to do, it's going to kick out a error message to you. So one of the things we have to do, and don't just assume that it's because my answer came out to be negative, is check your answer or check your work. If I plug that back in, will I get a negative value that I'm trying to take a logarithm of? And if I am, then we're going to have a situation where I don't have a solution. Okay, so you got to be very careful with that. And eventually, when we start changing things into common logs and are able to use the calculator, we'll show you ways to quickly go and check your work. Okay, so be careful with that. All right, good luck.